In this video today, we're going to be talking about the chemistry of hair. Chemistry is responsible for the beauty and diversity of hair. Keratin, found in the skin, hair, and nails, affects hair's chemical composition and texture, while melanin gives hair its beautiful and unique color. Alpha keratin is a polypeptide chain, which is a chain polymer made up of amino acid monomer units. All 20 amino acids have a basic structure which involves an alpha carbon connected to a COOH group, which is a carboxylic acid group, an amino acid group, and a side chain. Although it may appear as a trivial polymerization reaction, the formation of a peptide bond from amino acids is a complex process that is heavily regulated by enzymes, which are biological catalysts. The geometrical structure of alpha keratin is a trans configuration around the double bond, which reduces the steric hindrance between the side chains attached to the rest of the amino acid monomer. The peptide bond is planar, with all the atoms involved in bonding all in the same plane. This is because the peptide bond has partial double bond character, similar to an alkene. Apart from the peptide bond, the rest of the bonds are usually single bonds, and as a result, there's rotation around these bonds. This allows the protein, keratin, to curl around itself in a helix and be extremely flexible and strong. The main determinant for hair texture is the shape of your hair follicle. Chemical bonds stabilize the structure formed by the follicle. There are 4 types of bonding that occurs between the keratin chains: hydrogen bonds, disulfide bonds, ionic bonds, and van der Waals interactions. The amino acid cysteine, which is found in keratin, is responsible for creating strong disulfide bonds, which helps to stabilize the structure of the protein hair. All hair types have cysteine, but they are found more in curly and kinky hair types. This is what gives curly and kinky hair their distinct shape and texture. These bonds are the strongest because they are covalent bonds. Hydrogen bonds occurs between partially charged hydrogen and polar atoms, oxygen, nitrogen, and sulfur. These bonds are pretty strong interactions, but not as strong or as permanent as disulfide bonds. Ionic interactions and van der Waals interactions also occur between these side chains, which stabilizes the structure.
Hair color is determined by genetics and caused by 2 types of melanin: eumelanin and pheomelanin. Eumelanin is a darker pigment, while pheomelanin is a yellow-orange pigment found in redder areas. Eumelanin and pheomelanin are also responsible for skin and eye color. Since eumelanin is a darker pigment, high levels of it result in black hair. High levels of eumelanin and low levels of pheomelanin give you brown hair. Different variations of these levels give different shades and tones of brown. Blonde hair contains both eumelanin and pheomelanin, but contains low levels of both. More eumelanin would result in a darker blonde, while more pheomelanin would result in a strawberry blonde. Since pheomelanin is a yellow-orange pigment found in redder pigmented areas, it makes sense that high levels of pheomelanin and low levels of eumelanin result in red or ginger hair. Gray, white, and salt and pepper hair are not caused by certain combinations of pigment, but rather by the lack thereof. As we grow older, our body produces less and less melanin, resulting in gray or white hair as we age.
The 2 types of chemical bonds in keratin are non-covalent hydrogen bonds and covalent disulfide bonds. While blow dryers and flat irons rearrange the hydrogen bonds in hair, chemical straighteners rearrange the disulfide bonds due to the presence of additional chemical ingredients. Hair conditioners are vital in smoothing hair after washing with shampoo. It is made up of only a few ingredients, but it's the cationic surfactants that do most of the work. What are surfactants? Surfactants are compounds that have the ability to be both hydrophobic and hydrophilic by having both chemical groups with varying functionalities on the same molecule. Types of surfactants. There are 4 different types. This includes non-ionic, anionic, cationic, and amphoteric. Anionic surfactants are extensively found in shampoos to aid in removing oils and/or dirt. They carry a negative charge and are often accompanied by sodium or ammonium to balance the negative charge. Common anionic surfactants that are found in shampoos include sodium lauryate sulfate and sodium lauryl sulfate. Meanwhile, cationic surfactants are mostly used in conditioners. They carry a net positive charge as it binds with the negative charge of a hair strand. The attraction is so strong that the surfactants surround the strand and cover the cuticle flakes. The small amount of acid in the conditioner makes the cuticle flakes fall tightly against each other, making the hair feel smooth even after rinsing the conditioner out. Many shampoos contain these to provide some level of conditioning as well. Non-ionic surfactants are commonly used as emulsifiers, conditioning ingredients, solubilizing agents, etc. They have no charge and hence there is no ionization involved. Last but not the least, amphoteric surfactants contain both positive and negative charges. For this reason, they're used as secondary surfactants as they're neither good enough to clean nor function as well as emulsifiers. Hence, amphoteric surfactants are used in baby shampoos and other cleansing products due to its mildness.
Now we're going to talk about chemical alterations that can be done to the hair. Long-term alterations that we're going to discuss are hair perms and relaxers, and hair dye. So what is a perm? A perm is a chemical that breaks down and remixes bonds in the hair to make straight hair curly. The main component in hair perm is ammonium thioglycolate, aka perm salt. A basic solution of the perm salt is applied to the hair. Excess ammonia in the solution makes the hair swell so that the reagents can reach each strand of hair. The ammonia also deprotonates the thioglycolates. This thiol group is a reducing agent that breaks the disulfide bonds in the hair by protonating the sulfur atoms in the disulfide bonds. The separation of the disulfide bonds allows the polypeptide chains to become malleable and pliable. At this point, the hair is wrapped around a curling rod so that it can assume its new curly shape. Then it is covered in an oxidizing solution of hydrogen peroxide in order to re-strengthen the hair. This causes the disulfide bonds to reform, and the hair comes out of the bond in its permanent curl. So what is a relaxer? A relaxer is a chemical that breaks down and remakes bonds to make curly hair into straight hair. The structure of hair is in part due to the presence of cysteine, or disulfide bonds, between the keratin. A relaxer is then added to the hair. A relaxer can either be a lye relaxer or a no-lye relaxer. Lye relaxers are stronger bases, having a pH ranging from 10 to 14. They provide longer-lasting and more dramatic effects. No-lye relaxers are not as strong and therefore do not have as dramatic of an effect. A relaxer breaks down the cysteine bond by removing a sulfur atom. The addition of relaxer to the hair generates a new, more flexible bond called a lanthionine bond. The removal of a sulfur atom produces hydrogen sulfide and dihydrogen sulfide. Relaxers have very thick consistencies, and the loss of sulfur makes the hair weaker. This combination results in the hair strands being straightened and remaining straight. The hydrogen relaxer must be neutralized with an acid-balanced shampoo in order to lower the pH of the hair and neutralize any excess hydroxide ions. As demonstrated in this picture, the disulfide bonds in the hair are broken after the relaxer is applied. Next, we'll discuss hair dyes. I'm sure you already know what a hair dye is, but what is a hair dye? Hair dye is a chemical that changes the color of hair from one color to another. All hair dyes have a primary intermediate, which are often p-diamines or p-aminophenols. Two examples are paraphenylenediamine, or PPD, and para-aminophenol. The primary intermediates react with hydrogen peroxide, which oxidizes the intermediate and also lightens the natural pigments of the hair. Ammonia is present in the dye because the reactions need to occur at an alkaline pH. A basic pH allows for the hair to swell and therefore absorb the hydrogen peroxide and dye molecules. PPD and an oxidizing agent alone just produce a dark brown color. but that is not very useful if another color is desired. That is why coupling agents are also included in the dye mixture. Coupling agents react with primary intermediates in the presence of an oxidizer to make the dye molecules. These are some examples of coupling agents and the corresponding color that they produce once reacted.
Thanks for tuning in. I hope you enjoyed watching and learned something interesting. That's all, folks. See you next time.